So this question here, when you first look at it, it's really tempting to want to do cross multiplication, where you multiply the 5x plus 3 times the 1 and the x plus minus 1 times the 9 and move on solving the problem that way. And that is part of the solution. That's one way to approach it. But when you do that, you lose the fact that the denominators can become 0 because the denominators effectively go away when you do that. So first we need to find out what makes the denominator 0. And let's do that now. So we're going to set the two denominators equal to 0. And we'll do our algebra here on the left-hand side. We add 1 to both sides. And then we get that x equals to 1. That's pretty simple. Then on the right-hand side, we take away 3 from both sides. And then we divide both sides by 5. And we get that on the 5x plus 3 that x is negative 3/5. Those are the two numbers that will make the denominators equal to 0. So we need that information because, remember, those are our key numbers. Now we're going to find out what makes the numerator 0, and we can do that by doing the cross multiplication here. So we're going to take 1 times 5x plus 3, and I'm going to put in equals. I put it in red there to emphasize that I'm temporarily just saying equals because I'm trying to find the x that makes it 0. So that's why I've temporarily shifted here to equals. So we distribute the 1 times the 5x plus 3 and distribute the 9 times the x minus 1. And of course the left-hand side stays 5x plus 3 and the right-hand side becomes 9x minus 9. So we take away 9x from both sides and it cancels on the right, and then we're going to take away 3 from both sides to cancel out that 3. And when we balance the equation now, we get on the left negative 4x equals negative 12. All right, so let's move this over here so we can simplify a little further. Divide both sides by negative 4. And when you do that, you get x equals to 3. All right, and so that number is the number that makes the numerator equal to 0. And it's hard to see that now because if you look at the original problem, that's what faked me out. The first time I did this problem, I said, well, the numerators can't be made equal to 0 because they're 1 and they're 9. And you do find out through cross multiplication that they can be made to be 0. So now we have our key numbers of those three numbers, negative 3/5, 1, and 3. So remember, we set up our number line here. So I'm going to draw a number line. And we're going to list those points. So negative 3/5 is about right there. It's somewhere between 0 and negative 1, a little bit closer to negative 1. And then we'll put a point at 1 and 1 at 3 as well. And then, as we've discussed in class, we divide our number line up into these zones using a line there. So now let's test some values in these zones to see if they're true or not. So here's our original equation that we were given from the beginning, our original inequality. And so if x equals to, say, negative 2, I just picked any value less than negative 3/5. I could have used negative 1. I'm using negative 2 here for emphasis. So what that means is I'm going to plug in negative 2 into the problem that I'm given. So you plug in negative 2 for x in both places. And you simplify that down, you get a statement that negative 1/3 is less than or equal to negative 9/7. And that is not true. All right, remember 9/7 is a larger number. It's a little bit more than 1, but it's a negative, so it's more negative. All right, so that means it's smaller. So that is a false statement. So it's not true there. Then we move on and we say, what about if x equals to 0? Because that's my favorite number to check if I can ever check that. So you plug in 0 and you get negative 1 is less than 9/3 is 3. And in fact, negative 1 is less than 3, so that's true. All right, now we move on and let's pick a number between 1 and 3, and I like using 2. So if x equals to 2, what do we get? We put 2 in for x, and we get 1/1 is less than or equal to 9/13. All right, so 1 is on the left, that's a whole number 1, and on the right is a fractional number, 9/13, a little bit less than 1. That's not true, that's false. And then we check our last zone, which is to the right of 3, so let's use 4. So if x equals to 4, we plug in for 4, and we get 1/3 less than 9 over 23. So you might need to use a calculator there to confirm that one, but 1/3 is in fact less than 9 over 23 by just a small amount. So therefore that one is true. So we see this inequality is true in two places, in the zone from -3/5 to 1 and then from 3 on to infinity. And so we express that answer as from -3/5 to 1 union and then from 3 to infinity. Now if that was the end of the problem, that would be difficult enough as it is. And sadly, that's not the end of this problem. There's a little bit of trickery going on here. If you notice my symbols, I used parentheses in places and brackets in others. Right? See, I've used parentheses there. And then over here, I used a bracket. So why did we have to use parentheses on the left? What happens is remember, -3/5 and 1 are the two numbers that make the denominator 0 in the original problem. Right, and so the original inequality, although it is a less than or equals to, 1 causes the left-hand side to be 0, and -3/5 causes the right-hand side to be 0. So we can't actually be equal to those numbers because that makes the denominator 0. But we can be equal to 3. 3 is what made the numerator 0 when we did our cross multiplication. So we can be equal to 3, but on the -3/5 and the 1, we must use parentheses because being equal to those numbers would cause the original inequality to be undefined. So hopefully this demonstration shows you this problem and how it works. And if you have any questions, just let me know.